Using functions to model linear relationships, lesson 15, example number 3. Lucas picks apples at his aunt's orchard. His aunt pays him a daily wage plus an additional amount for each bushel of apples he picks. The table shows his daily earnings Y if he picks X bushels of apples. Write a linear function that models the situation. Identify the initial value and the rate of change of the function. Then graph the function. So in the chart, it's telling you if he picked 1 bushel of apple, he's going to make $38 for that day. If he picks 2 bushels of apples, he'll make $46 that day, and so forth. It is telling us that this is linear. I want you to go back up to the paragraph here and see where it says write a linear function. That's just another way of saying write a linear equation. So let's put linear equation. When they say write a linear function, I want you to know that that means just write your linear equation, your y equals mx plus b. Okay, now if you remember from the previous lesson for linear and nonlinear functions, that we would find the slope between points. Like, do you remember doing this? And if the slope was the same the whole way throughout the problem, if it was exactly the same, the ratios were the same, then it would be linear. If it's not the same, it would be nonlinear. Well, this is telling us that this is linear. So that means it doesn't matter which points I pick, I'm going to get the same slope. So my suggestion would be pick the numbers that are smaller, the numbers that are easier. So let's pick the 138 and the 246. So remember, we're going to subtract from the bottom up. 46 minus 38 is 8. 2 minus 1 is 1. So our slope is 8 over 1, which means our slope is 8. So let's go down underneath the chart here, and let's write that the rate of change is $8, because right there it's telling me it's money, $8 per, that's not per hour, it's per bushel. So that means Lucas makes $8 per bushel that he picks. Well, now we need to find the initial value. And there's 2 ways to do this. Remember, the initial value, your y-intercept, is the value of y when x is 0. The value of y when x is 0. But unfortunately, I don't have a 0 in this x column. So one way to do it is what we did a long time ago, and we used point slope form. Now this is going to be the harder way, so I want you to actually put harder method. And we're going to use point slope form, which means we put y minus y1 equals the slope times x minus x1. Do you remember doing this? We did this several lessons ago. So let's pick this top point right here. So it'll stay a y. And then the y1, the y coordinate would be your 38 equals your slope. Well, your slope is right there, your 8, times x minus your x1, which is 1. All right, I'm going to erase these circles up here now. All right, to finish this, first I need to do the distributive property. So y minus 38. 8 times x would be 8x. 8 times negative 1 would be negative 8. Then I need to isolate the y because I need it to be y equals. So to isolate the y, I use the inverse operation to get rid of the 38 since it's a negative 38. I'm going to add 38 to both sides. Again, we've done problems like this, so you should understand what I'm doing. So those would cancel out. So my equation would be y equals 8x, negative 8 plus 38 would be 30. So this is my equation. That's my linear function. So that means my rate of change is the 8, and my y-intercept, my initial value, is the 30. Like I said, that's the harder method. So Now I'm going to show you the easier way of doing this. Let's see, let's put easier method. To find your initial value, your y-intercept, you're going to take the value of y when x is 1. You're going to take the value of y when x is 1 and subtract the slope. And that will give you your y-intercept. So I'm going to take the value of y when x is 1 and subtract the slope. Well, if I go up to my chart here, here's where x is 1, here's my y value. So I'm going to put that beside the 38. So if I take 38 minus my slope, I get that my initial value, 38 minus 8, is 30, which isn't that what we got over here? One more thing. Just so you remember, I want you to put this. Let me make it larger. So this means it is the value of y when x equals 1. So if they give you a chart where x equals 1, look to see what the y value is, take that y value, subtract the slope, and you've got your initial value. All right, so now we've got our equation. Let's go ahead and graph. Well, my initial value, my y-intercept is 30. So I'm going to go to here and put a point. My slope is 8. Well, these lines are not going up by 8. However, they are going by 10s. And if you look at your chart, box this right here is a multiple of 10. So I'm going to use that ordered pair to finish drawing my graph. So I'm going to go over to the 5 and up to 70. And starting at the 30, go through the 70. Put my arrow only at the one end because you can't pick a negative number of bushels and you can't take negative money. So it's going to be only positive numbers in the first quadrant. Okay, so that is example number 3. If you have any questions, let me know. One more thing, I'm just going to highlight this down here because this was very important. Very important. I'm going to make it a little lighter so we can see through it. There we go. So you want to find the value of y when x is 1, subtract the slope to get your initial value. Okay, if you have any questions on example 3, let me know.